right, so there's some more. And then, of course, we have all these in-between angles. Now, one thing I do want to mention before I move on to the in-between angles, okay? One place where students will mess up is right here. I do want you to put both 0 degrees, 0 radians, and 360 degrees and 2 pi radians there for that same kind of spot, okay? I do want you to do that. So, you know, for tomorrow, please don't miss 2 points because you forget to do the 360 and the 2 pi there. All right, that is part of the quiz, all right? So then comes some other angles, right? These other angles that are important, and they're important because essentially they come from 2 special right triangles, right? A 45-45, 90 right triangle and a 30-60, 90 right triangle, and that's why we bother putting them on here at all, okay? And so each quadrant is going to have 3 of those angles, and you can kind of put them just, you know, roughly something like that. You know, it's not going to be super necessary for exact, you know, placement and stuff like that. But anyway, we're going to do 30 degrees in that first quadrant, which ends up being pi over 6. We'll have a 45-degree angle, pi over 4. And then we have a 60-degree angle, pi over 3. Okay? Pi over 3. The pain here, right, is that these numbers aren't evenly spaced, right? From 0 to 30, that's 30 degrees. It'd be really nice then if we went another 30 degrees, but we don't. We go 15, and then another 15, and then 30. So it goes, you know, 30, 15, 15, 30. So we're not advancing by the same amount each time. Okay, there is a pattern to it. It'll be the same. It'll be that same pattern where it goes from 30, 15, 15, 30. It would be another 30, 15, 15, 30, and 30, 15, 15, 30, 30, and 15, 15, 30 as well. So, you know, but it doesn't go by an even interval every time, right? So that kind of makes it tough. A little bit tougher to memorize that. Okay, but there's your radian measures there. Of course, you can get those by converting or by just memorizing it too. Okay. All right, next 3 angles then, the corresponding angles in the second quadrant for that, okay, it's going to be 120 degrees. It'll be 135 degrees, and it'll be 150 degrees. Okay. Which is then 2 pi over 3, 3 pi over 4, and 5 pi over 6. Okay. So again, you can come up with all sorts of patterns here if you want to. You know, you can see, for example, that it goes, you know, the denominators go 6, 4, 3, 2, 3, 4, 6, and then, well, 1, I guess, if you want to say it there, okay, for pi. 6, 4, 3, 2, 3, 4, 6, 1. And I'll go the same way over here for this kind of quadrant too. So, and so let's see here. After the 180 here, it'll be then 210 degrees, then 225 degrees, and then 240 degrees, which equates to 7 pi over 6, 5 pi over 4, and 4 pi over 3, kind of correspondingly there. Okay. And then lastly, we'll have, I guess I'll do it this way, we'll have 300 degrees, 315 degrees, and 330 degrees. And their corresponding radian measures of 5 pi over 3, 7 pi over 4, and 11 pi over 6. Okay. And so there's your first quiz for tomorrow. That's your answer key. Okay. You have 3 minutes to reproduce that on your own, without a calculator or without your little sheet and stuff like that. Okay. And again, just some things to help you figure this out, right? In the first quadrant, it's just pi, pi, pi in the numerator, and then it's, the 643 or the 346, whatever, 6432, whatever you want to remember there. In the second quadrant, all of the numerators are just one less than their denominator, right? So 3 and then 2, 4, 3, 6, 5, right? So just down 1. In the third quadrant, it's similar to that, except it's just they're all one more. 6 in the denominator, 7, 4 in the denominator, 5, 3 in the denominator, 4, 2 in the denominator, 3. And then in the fourth quadrant, okay, the numerators are all one less than twice their denominators. So like 6 minus 1 is 5, 8 minus 1 is 7, 12 minus 1 is 11. Okay. Don't know if that's helpful, but that's the idea there. Okay. The idea is really all of these angles and all of these angles here in both degrees and radian measures, right? You can kind of, measure them off of this x-axis. Okay, so for example, from the 0 degrees, we go up 30, 45, and 60, but then from 180, we go back 30, 45, and 60, right? 180 minus 30 is 150. 180 minus 45 is 135. 180 minus 60 is 120. And then from these sides, we also can go off like that. So again, 180 plus 30, 210. 180 plus 45, 225. 180 plus 60, 240. 360 minus 30, 330. 360 minus 45, 315. 360 minus 60 is 300. Okay? So it's really all just going either back or forwards 30, 60, 30, 45, and 60 degrees from these two sides. And then in radian measures, it's the same idea we're using now. Instead of going back, instead of going up 30, it's going up pi over 6, up pi over 4, up pi over 3. So going back pi over 6 from 6 pi over 6 would be 5 pi over 6. Going back pi over 4 from 4 pi over 4, 3 pi over 4. Back pi over 3 from 3 pi over 3 here is 2 pi over 3. And then adding on, adding a pi over 6, adding a 5 pi over, adding a pi over 4, adding a pi over 3 gets us that, and then subtracting from the 2 pi. Same kind of idea. Okay. So lots of different ways to remember this. However you want to remember it is fine. Again, you'll hopefully build some more understanding behind that memorization as we go. Okay. And not just have it be a bunch of numbers that we just memorize and then eventually forget, but hopefully being able to come up with a way to then recreate it. All right. There's going to, like I said, there's going to be 5 of these time trig quizzes, 5 of them. Okay. I'm not going to have all 5 be like each one won't count as a full quiz grade. So the 5 quizzes, I will then, get your total amount out of those 5 points, and I think it ends up being like out of 80 total points, if I'm not mistaken. Anyway, I'll get you the score, the total for those 5 quizzes, and then I will make it proportional to 2 quiz grades. So the 5 timed quizzes will end up counting for 2 quiz grades. Okay, I'll just do a ratio of your grade and stuff like that. So whatever you get out of those 5, whatever the total points you get out of those 5 quiz grades, the total grade you get for those 5 will then just become 2 quiz grades worth. Okay, so that's the idea. All right, and this, like I said, will be tomorrow's quiz. Tomorrow's quiz will already have the circle, and I showed you what it is. Again, there's what your quiz will look like tomorrow, with your name and date there. Okay. There is the answer key that I'll be using. Notice again, the 360 and the 2 pi is there. Okay? So you can go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, and then 34 points, right? 2 points, 1 point each for the radian and degree measures. Okay? Questions on any of that? Something to look forward to tomorrow, right? All right. But don't worry, it'll all be done before spring break, so when you go to spring break, you can forget all the trig that you ever learned, and then we'll come back and have to relearn it all again. So it'll be great. All right, so you want to hold on to that. Okay. In the meantime, let's get into what we're going to do today then. Okay. Which is solving right triangles and talking about our trigonometry ratios, right? All right, hey. All right, so we're going to reintroduce these trig ratios that you guys first saw in geometry. and then probably saw again in Algebra 2, and now we're going to show them one more time here in pre-calculus. Okay? So, trig ratios, right? All right, we have the sine function, abbreviated SIN, okay, but not sin, it's sine, right? Okay, we have the cosine function, abbreviated COS. We have the tangent function, abbreviated TAN. Okay, these are all buttons in your calculator, right, you can use to help you. Sine, cosine, and tangent are ratios that relate the angle of a triangle, of a right triangle, to a ratio of two sides of that right triangle. Okay? And then we also have three other trig ratios that I think sometimes people are less familiar with, right? So we also have, for example, cosecant of x, abbreviated CSC, cosecant. We also have secant of x, SEC, abbreviated, and then cotangent of x, okay, abbreviated like so. Alrighty. Excuse me. Okay. So those are our 6 trig ratios that, for which we'll be responsible, okay, for using these in different ways. All right, and of course, you know, let me draw a right triangle here to kind of show some of these relationships. So, for example, let's say that I've got this right triangle, and then, I am not drawing this to scale at all, but that's okay. Okay, and let's say it's a nice Pythagorean triple right triangle, right? All the side lengths here are whole numbers, 3, 4, 5. Classic right triangle, classic. Okay, now we name some angles here. So I'll call like this angle A, and I'll call this angle like B. And so then let's say we want to, find the 6 trig ratios for angle A. Okay, let's say that's what we want our directions to be, right? So it's pretty straightforward, pretty simple stuff, hopefully. Okay. So sine, cosine, tangent, cosecant, secant, cotangent, right? They're inputs. The thing you put in for x, this is an angle. All right. So we should always take the sine, cosine, or tangent of an angle. You plug an angle into a trig function, and then it spits out. Its output is a ratio of two sides. Okay. So if you remember back to your trigonometry from before, I think I can squeeze this in here. Okay. Sine is equal to the ratio of what two sides in a triangle? What over what? Opposite over hypotenuse, right? The side or the leg, opposite leg, I'm going to abbreviate opposite over the hypotenuse. I'm going to abbreviate hypotenuse as well. So it's the opposite leg over the hypotenuse, right? What's cosine? Adjacent, and I'm going to adjacent leg. Okay, because the hypotenuse technically will be an adjacent side there, and sometimes people want to put the hypotenuse. I don't think I see that so much in pre-calculus, but sometimes students do it still. Okay, so it's the adjacent leg of the hypotenuse, and then tangent, its ratio is what? Opposite leg over the adjacent leg. Okay, I did kind of squeeze it in there. Okay. Device that we have to remember that is SOHCAHTOA, right? Okay, so I'm not going to have any space to rate that here, so I'll just put it up here. Okay, very important that you spell SOHCAHTOA correctly, or else you're going to mess up your ratios. And when I was in geometry in high school, I almost failed or did fail a geometry quiz because I misspelled SOHCAHTOA. I spelled it SOHCAHTOW, T-A-O. That messed up a lot of my answers. Whoops. Okay, so don't do what Mr. Witt did. Okay, so we have sine, cosine, and tangent there, but we also have those cosecant, secant, and cotangents. Okay, those are the reciprocal trig functions. Okay, so what's cosecant's ratio? It's hypotenuse over the opposite leg. So you can see it is the reciprocal of sine. Okay, sine and cosecant are related in that they are reciprocals of one another. They are reciprocal trig functions. So therefore, secant, right, you can kind of maybe see how I wrote these things if you didn't see it earlier, will be just the reciprocal of cosine. And by the way, I think this is like the dumbest naming I've ever seen. Why would you make the reciprocal of sine be cosecant? Why not just make sine and its reciprocal be secant? I will never understand that. And I've tried to Google it and figure out how these things got named, and I couldn't find anything. So maybe there's a reason for it, but to me this just seems like the dumbest. Why would you do that? But there it is. Of course, you guys are probably like, why do you do a lot of things in math? And I just do those without questioning. So anyway, and there's reciprocal cotangent. Okay. And the mnemonic device for this, right, is Choshikow. All right. Choshikow. Okay. So if you forget, right, SOHCAHTOA and then Choshikow. And there it is. All right. Easy. And of course, if you want to put this on that little, sort of cheat sheet there, you can feel free to put that, or at least write SOHCAHTOA or Choshikow. Those are some good things to remember. Your trig ratios. What's that? Not on tomorrow's quiz, but it's going to be helpful for you to remember that, I think. Yeah, in general. All right, so let's actually do this here for angle A then. So we want to find the sine of angle A. We want to find the cosine of angle A. We want to find the tangent of angle A. And then, of course, those reciprocal trig functions, cosecant of angle A, secant of angle A, and then cotangent of angle A. Okay. I don't really care the order that you do these, in which you do these, right? I don't really care in what order you do these problems. I like to typically stay with the same order. I normally do sine, cosine, tangent, just because that's what it is with SOHCAHTOA, and then I try to be very careful that I write their corresponding reciprocal trig functions in that same order, because I feel like I just get mixed up otherwise. But you can do whatever order you want. If you want to start out with, secant, and then do tangent, and then whatever, jump around, it's fine. But anyway, sine of angle A, all right, remember, so that sine is opposite over hypotenuse. So opposite angle A is 4 over hypotenuse 5, so 4/5. Okay, and that's just ratio there. Cosine of angle A, adjacent leg 3, and then 5 is hypotenuse. Okay, and then tangent of angle A, opposite leg 4 over adjacent leg 3. And then, of course, excuse me, cosecant will just be the reciprocal, so it'll be 5 over 4, 5 over 3 then for secant of angle A, and then 3 over 4 for the cotangent of angle A. So there they are. Pretty straightforward there. All right. So let's see here. Let me give you guys one try. Okay. Draw a triangle here. And let's just say find the 6 trig ratios for angle theta. All right? That is a Greek letter often used to describe, or to name an angle. Theta. T-H-E-T-A. Theta. Okay? Greek letter theta. And so we'll just put this here, and then this here, and then this here. Okay? So go ahead, find those 6 trig ratios for angle theta. Okay, go ahead and find the 6 trig ratios there for angle theta. Give it a try. right, so let's get some of these ratios here. So let's see here, sine of that angle theta. You can put a little angle symbol in there if you want to. If you just want to leave it as theta, I was putting, angle A here, but if you just put the theta, that's okay too. You don't have to put the angle symbol. Okay. But Sarah, let's go here. To you, sine of theta is what? 1/2. 1/2. Very good. All right. Cosine of theta. Let's go to Nick. Nick, what's the cosine of theta?
It says √3/2.
√3/2. Nick, how did you get √3? I didn't give you that side.
I used the Pythagorean theorem.
Right. Remember, right, folks, this is a right triangle, and you can use Pythagorean theorem to relate the three sides of a right triangle. If you know two sides of a right triangle, you can find that third side by using the Pythagorean theorem. All right, remember that Pythagorean theorem, right, is leg squared plus leg squared equals hypotenuse squared. Okay. Just saying a squared plus b squared equals c squared is, yeah, that's what the letters that you use, but it's important that you put the right right side in the right place, right? So a and b have to be the legs of the right triangle, c is the hypotenuse, so the 1 can go in for a or b here. Hypotenuse goes in for c, and so we get 1 plus b squared equals 4, and so we get b squared equals 3, and so we get b equals the square root of 3. Okay. Technically, since we're in an equation setting, right, square rooting both sides here would yield a plus or minus 3, but of course, we're talking about a triangle. It doesn't really make sense for a triangle to have a side that's at negative square root of 3 in length. So we throw out the negative √3, we just use the positive. All right, great, very good, Nick. All right, so tangent of theta, let's go to Denny. What do you say, Denny?
I messed up the 1 0.
Okay, gotcha.
I think it's 1/√3.
I was going to say, yeah, I got my picture up there for you. So yeah, it'd be 1 over the square root of 3, or if you rationalize that, it would be √3/3. Okay, or if you rationalize it, it would be √3/3. All right, and then let's go cosecant of theta, and we'll go to, someone who's here. Morgan, what'd you get for cosecant of theta here, Morgan? 2/1. Okay, yep, just the reciprocal there. Okay, cool. How about Lindsay, cosecant?
2/√3.
2 over the square root of 3, or again, if we rationalized it, 2√3/3. And then cotangent of theta, excuse me. Stella, cotangent, what'd you get?
I just got 2/√3.
Yeah, just square root of 3, exactly right. Okay, and there it is. Okay, questions on any of that? All right, so when it comes to evaluating trig functions, okay, I know this seems like silly to devote a section of our notes to this. Well, it will seem silly once I do it, but I'm going to do it anyway. Okay. So let's just say we want to evaluate, sine of, I don't know, like 135 degrees. Okay. Sine of 135 degrees. All right, you're going to type into your calculator here. Let me turn the light on. There it is. All right, so there's the sine button, right? You're going to press sine. You're going to type in 135, and you're going to hit enter. And you get this, 0.08836868861. Okay? Yes?
I got a different answer.
What? That's right. I'm wrong. Okay? So, and you're going to get it wrong if you do that. Sine of 135, in my case, you get it wrong. Why? Because you got to press the mode button. All right? And then there's this option to toggle between radian and degree measures. Since we are clearly evaluating a degree measure here, we want to adjust that to be in degrees. All right, and now when we go and evaluate sine of 135, we get 0.707. Okay, so we'll approximate that to 3 decimal places, please. All right, and so the key here, and the reason why I do spend time on this, okay, is not because I doubt that you can push buttons on a calculator, all right, but it's when you have trouble, remembering to switch, right? Because we do move back and forth in this unit, or in future units too, between degrees and radians. And so, if I ask you to find the cosine of, like pi over 6, okay, that's clearly in radians now, so we would then have to readjust our calculator, pressing the mode button, go into radians, and then doing cosine, and then pi over 6, right? The pi button, remember, is right there above that. Well, you can barely see it. There it is. Okay, it's above the little caret there. It's pi. Second caret there. Okay, and so you get like about 0.866. Okay, again, I put the squiggly equal sign to indicate that it's not an estimate, it's a rounding. We rounded it there. It's not exactly equal. Okay, so that's just that little thing. Okay, I'll get off my soapbox here, or whatever, but just so we know that we can evaluate trig functions with our calculators. One last thing I want us to be able to do then is to also be able to solve for sides. All right, we'll get to solving for angles in a little bit. I'm not going to worry about that right now, but I also want us to be able to solve for sides, for missing sides. Okay, so let's see. Yeah, okay. And again, I'll just do maybe one or two examples here. I'll do one and I'll have you guys try one. Okay, so there's my right triangle, and let's say that I got x here. We'll say this is 30 degrees here, 60 degrees here. We'll say that's 4. And so let's say we want to solve, find x. Okay. So it's a right triangle, so I can use the Pythagorean theorem. Is the Pythagorean theorem helpful here? Why not? We have two missing sides, two unknown sides, right? Pythagorean theorem, we can only really use it. It's got 3 variables in Pythagorean theorem, right? And we have a single equation with 3 variables. That means you need to know 2 of them in order to solve for that third one. Okay, since we're missing 2 sides here in a right triangle, we can't use Pythagorean theorem. And so we're going to use one of our trig ratios. Okay, and we have some options here. Okay, we can kind of pick one of our angles. We never really pick our 90-degree angle to solve for. I don't really have a good reason for it other than it just won't work. All right, we want to pick one of our acute angles here, 30 or 60-degree angle. So if we pick 30 degrees, which trig ratio would we want to use to relate the sides? Okay, so we have the opposite leg, that's 30, right? We want to find the opposite leg, and we have the hypotenuse, so we would use what trig ratio, sorry? Sine, right? Or if we chose to use the 60-degree, I see you, Anna, I'll be right with you 1 sec. Or if we use a 60-degree angle, we now have, this is the adjacent leg we want to solve for, and we have the hypotenuse. So what trig ratio we use there? Cosine, right, okay? So it would be the same way, same thing either way there. Anna, did you have something you want to say, or? Say what? Oh, yes, yeah. We're going to get to that, though, all right, but yes. So you can use whichever one you want. I'll use sine here. So sine of 30 degrees, okay, is equal to the opposite x over the hypotenuse 4. Okay. And so if you want, which is not a bad idea, we can solve for x right now. We'll just say, okay, we'll multiply both sides by 4 here to get the x by itself. And so we have that x is precisely 4 times the sine of 30 degrees. Right? That is exactly what x is equal to. And then we can type into our calculators and see what kind of, value we get. Make sure you're in the right mode. Okay? And you should get 2. As Anna said. Okay? 2. Okay? So here, I'm going to have you guys try one. Same idea, just solve for the missing side here. Let's see. Not being very creative with my triangle shapes today. Alright. Okay, and again, just solve for x. Solve for x. Okay. So if you remember from before, I told you that secant is just the reciprocal of cosine.
Yeah.
So if you want to do secant, you just write in your calculator 1 over cosine
Okay.
of x. Or you just find the cosine of x and then just do the reciprocal of your answer, 1 over your answer. Right. Let's see here. So let's go to So Andrew W. Come to you again. What'd you get? Did you get an answer yet?
No, but I can get one really quick.
Okay. I'll give you
One sec.
time here.
I got 9.7724.
Okay. 9.7724. All right. And you got that by doing what? What was your setup here?
I did sine of 67 equals 9 over x.
Ah, very interesting here. So you found the complementary angle here, 67 degrees, and then you chose to use sine. Okay, so you said sine of 67, and you said it was equal to, I'm sorry, what?
9 over x.
9 over x, 7 degrees. Okay, and so then how did you go about solving this at this point? What did you do?
Multiply both sides by x.
Aha, right, we need that x out of the denominator, right? Sometimes you'll have your variable, your ratio will end up with your denominator. Sorry, your ratio will end up with your variable in the denominator. So we want to multiply both sides by x to get it out, and then what from here?
Divide both sides by sine 67.
There we go. So we have x times sine 67. We want to then divide it over. So we have 9 over the sine of 67 degrees. So we type that into our calculators. And again, make sure I'm in the right mode. I am. And I got 9.777. 243397. Okay. So we'll say that's approximately 9.777. All right. Very good. Right, lots of options there. Some of you guys have used cosine. All right, it sounds like, Sean, you use secant then to do this one? Yep, secant would work as well. Okay. Pretty much everything would work except for, I guess you could use tangent, but then that would be like very roundabout, because then you'd be solving for the opposite side, or that other leg there. But anyway, tangent could be helpful there, in a way. All right, so, any questions on any of that? Pretty straightforward stuff. That's like probably a review mostly from stuff that you learned in geometry right there, but we'll take it up a few notches here in a little bit. Don't worry. Okay. So in the meantime then, let me give you guys your assignment. That's all I've got for you today. Okay. I don't want to put too much on your plate since we got our first time trig quiz tomorrow. So
No, that's mine.
if you would please, get started on page 306, numbers 6, 8, 63, 64, and 71. Okay. 6, 8, 63, 64, and 71. All right.